Hello, I'm Richard Rasch. It's great to have you here. I'm going to be talking about tailoring digital elevation models for maps with small footprints and the way I use this data to add important details. So just a bit about me. I'm an avid disc golfer. I've been mapping courses since 2000. I'm a member of the Professional Disc Golf Association. There is such a thing. Been using MAPublisher since 2001. I'm the owner of Custom Course Maps based in St. Paul, Minnesota. I established that in 2012. And in 2014, I started installing signs in courses, and so far I've been able to complete that for 24 courses in 8 states. When I started playing disc golf, I noticed maps were not very accurate or detailed. No scale, no distances, no orientation. There seemed to be plenty of room for improvement. What I'm going to share with you today is a process I used for the Oakwood Park disc golf course, and how I took the signage from this to this. But first, let's briefly talk about how disc golf is played and how courses are usually installed. Like traditional golf, you start at a tee area and throw the disc. The disc needs to land in the basket to complete the hole, and notice the terrain. It can be flat or on a slope like it is here. The disc can bounce or roll away. The pavement is considered out of bounds, like landing in water. The fairways have a lot of variety, from a temporary setup on a traditional golf course to fully mowed areas in neighborhood parks, and notice there's nothing distinguishing these two fairways. And here is a similar situation. All of the park is mowed, so the fairways are not obvious. You see on the far right there's a paved parking lot. If you land in that, you're out of bounds, but landing anywhere else, you're on the fairway. And for the second shot, as you approach the basket, there's still no distinct fairway and no green. And you can see disc golf courses blend in really well. Sometimes only landing areas are mowed and you have to throw over tall weeds. This fairway can feel crowded, and with more objects in the way, your view is obscured and your ability to judge distance is hampered. Having a detailed map is again very useful. Fairways can also play completely in the woods and under tree canopy. If the hole is long, it isn't possible to see the difficulty from the tee. Often terrain and other park features like pavement, trees, bushes create the challenges of each hole, so mapping these details is important. To explain this picture, once you make it up the fairway to this spot, you have to navigate over the out-of-bounds road and around the low-hanging branches and climb the hill on the other side. A detailed hole map on the tee sign will help explain what lies ahead. So let's take a look at this from a different angle. Traditional golf courses are easy to recognize in aerial imagery. Here you can easily see the 18-hole and the 9-hole courses. There's also an 18-hole disc golf course here. Do you have any idea where it is? It's right here. This is a good example of how small the footprint for a disc golf course can be. Notice even after we zoom in, there's nothing to indicate a course exists. Again, fairways in disc golf are often not delineated. Some areas where the grass is worn away around the tee pads and the baskets is visible, but only a map will reveal the actual layout. Again, the high-resolution digital elevation model provides hillshade and contour lines that help emphasize terrain. The DIM also provides a way to calculate the elevation gain or loss for each hole. And here's the full map. Remember the fairway under tree canopy? Here's an entire 18-hole course completely hidden in the woods. This leaf-on aerial imagery fully obscures the course. But even a leaf-off image doesn't help much, although it's possible to detect some stream beds and footpaths. You could place the fairways, paths, and streams over the aerial imagery, but it's much more compelling to see the terrain detail provided by the high-resolution DIM. This gives a more complete picture of what is happening under canopy. To complete this map, we only need to add some individual trees along the fairways and fill in the remaining area with an overlay of woods. But let's move on and talk about the workflow here. When I started playing disc golf 25 years ago, I was teaching computer graphics, which included how to use Adobe Illustrator. Eventually, I purchased MAPublisher to import tiger line shapefiles into Illustrator to help speed up the map making process. This turned my attention to GIS data in general and how it could help enhance detail. This process starts with two sets of data, high-resolution DIMs and GPX files of waypoints and breadcrumb trails collected in the field. I use QGIS to create the raster base layers of terrain and the shapefiles of contour lines. Being able to import and register them in Illustrator is key. I also export shapefiles out of Illustrator and back into QGIS for further elevation analysis, so MAPublisher is the ringmaster. You notice Claris FileMaker over there on the side, and it may not be familiar to you. It's a relational database that will carry out some of the repetitive tasks needed for each T-sign. The layouts in FileMaker can be exported as PDF files and placed back into Illustrator. We now see that disc golf courses take up about 1/3 of the area of traditional golf. So course maps are large-scale, small footprint maps covering areas of less than 100 acres. Lidar-derived DIMs need to be 1 meter or higher resolution to be useful at this scale. And bare earth DIMs are the most useful for this work and save time by not having to process Lidar point clouds. You can see from the chart that the USGS has defined the quality levels for Lidar data, and this is good news because more areas are covered by these high-quality DIMs each month. As an example of detail, the contrast between the islands in a parking lot can be easily detected by high-quality Lidar. They are easy to see in this hillshade example on the right. These high-resolution DIMs will highlight details you want, and some you may not. Here is a hillshade view of a DIM that I will use to make contour lines. Notice, like the parking lot islands, there are many bumps. Contour lines created from this meander too much and will be distracting when I zoom in to create the T-signs for this project. But rather than trying to smooth the contour lines, what I do is heavily blur the DIM and then recreate the contours. The effect on the whole is more attractive. The final step to emphasize terrain is to add a pseudo color ramp with a darker green for lower elevations and a lighter yellow for the higher elevations. This will be the base layer for all the maps. There is no scale for this map, so let's take a look at an aerial image of this location. Again, the aerial view obscures the terrain. With MAPublisher, I can register a geo-referenced aerial of the park. I'll use this image to digitize infrastructure like pavement, buildings, woods, and trees. I'm going to skip over that for now and focus on mapping what we can't easily see. Here I will use the GPX data collected in the field. Adding the waypoints of the T's and baskets to the georeference aerial shows their correct location. I'll also add the breadcrumb trail collected while I walk to each location. Tracing features this way makes it easy to add details obscured by the woods. In this case, it will help determine the true shape of some of the fairways. Can't have too many breadcrumb trails. And here's a few more. Next, the GPX data used in Illustrator is also imported into QGIS to sample the elevation contained in the DIM. The 1 meter resolution will provide an accurate vertical elevation for each waypoint location, which will be exported as a CSV file for the FileMaker database. The database will be used to create information panels for each T-sign. It calculates the distance, the change in elevation, and the bearing of each fairway. All of these numbers would need to be arranged individually in Illustrator for each T-sign. Instead, the database will export these panels as PDFs, which will be placed over each T-sign map. Now we can build the course map. It begins with the terrain base layer I created as a raster image in QGIS and registered with MAPublisher. Then I add the contour lines that I created from the DIM and imported as a shapefile. Next, the digitized pavement and infrastructure. The footpaths in the upper left were created from some of the breadcrumb trails. Then I add the trees, the woods, and the area around the marsh. Finally, I add the fairways and finish with a scale bar and a compass rose. The map is added to the kiosk sign along with the key, distance chart, rules, and branding. As a reminder, this was the original, and here's how the new, more detailed and accurate map looks. The T-sign detail is important. The bearing that was calculated for each fairway is used to rotate the map in Illustrator, and an artboard is created to export the T-sign map. Each T-sign will be cut out this way. This allows me to include adjacent fairways. You can see 2 of the fairways ghosted in gray. One of the challenges of the smaller footprint of disc golf is navigating the course. Fairways in traditional golf are often isolated so that only the pin in play is visible. In this image, there are 4 baskets visible from the long tee of hole 3. The T-signs incorporate the visible items from other fairways, for example those baskets. Since MAPublisher allows measuring real-world distance, I've also added downrange distance markers to help estimate distances for your tee shot. Now, let's take one more trip back to QGIS. I imported the fairways as shapefiles, and I'll use the DIM to create an elevation profile of the fairway. Understand that using high-resolution 1-meter data will yield a very useful profile. I have recalculated the DIM from meters to feet and sampled this profile while using the Minnesota State Plane projection that is also in feet. The profile is exported as an SVG. The SVG on the bottom is then stylized to reflect the pseudo-color terrain, and the thrower and the basket graphics are added for clarity. I created profiles separately for the T-signs as needed, but only for those fairways with significant change in elevation. Now the profile is added to the T-sign, along with the information badge and labels. This particular poorly made map from hole 8, aside from distance and hole number, lacks available detail. The updated sign includes other fairways ghosted in gray color. This detail helps with orientation as you make your way through the course. So tying it all together, here's how the kiosk looks in the ground, and the T-signs are ready to deliver. And also want to add that when I'm not mapping courses, I still enjoy playing. Thanks for joining me, and reach out if you have any questions or want to talk in more detail about tailoring digital elevation models for maps with small footprints. Thank you.